Everyone. So in this video, we're going to be learning a formula that will allow us to take a logarithm with any base and translate it to express it in terms of logarithms with any other base. So the advantage of this is that we'll be able to take logarithms that we cannot evaluate by hand and translate them into a type of logarithm that a calculator can handle. So you'll see more about what I mean by that a little bit later. So just to give you a little bit of context, so far in this class, we've really focused on what I would describe as kind of nice logarithms. And so what do I mean when I say nice logarithms? I mean logarithms that you can easily evaluate by hand. I'm just going to say logs instead of logarithms. Logs that can be evaluated by hand. And so what I mean by that is something like log base 5 of 25, right? So log base 5 of 25, we know that that equals 2 because we can just look at 5 and 25 and say, okay, I know 5 squared is 25. Or another example would be like log base 9 of 3. So log base 9 of 3, you can say, I know that the square root of 9 is 3, and so it means I would need to raise 9 to the 1/2 power. But those aren't the only kind of logarithms that are out there. So remember when we learned about logarithmic functions, and we thought about logarithms as being functions, the domain of a logarithmic function is all numbers greater than 0. Remember, if you think about what the graph looks like, it has that vertical asymptote at 0, and then everything else is filled in. And so what that means is that you can evaluate a logarithm for any number greater than 0. So we can actually evaluate the logarithm, and I'll just say the logarithm, but I mean with any base, of any number. I'll say it like any positive number, right? That's the same as saying any number greater than 0. So an example of what I mean by this is, let's say we wanted to figure out what log base 5 of 12 is. So this is not one that we can just kind of look at and figure out, right? Because essentially what this is asking us to figure out is, what power do we need to raise 5 to get 12? And so your answer might be, well, there is no power, right? There's no number that we can think of that we can raise 5 to and get 12. But that's actually not true. So there's no whole number power that we can raise 5 to and get 12, but we'll see that there is actually a number. It's going to be a funny decimal. It's not one that we would be able to come up with just by looking at it, but there is a power that you can raise 5 to and get 12. There's actually always going to be some exponent that you can raise any base to and get any other positive number. So let's try to estimate what this question mark would be. So how could we go about estimating what we think log base 5 of 12 is going to be? Well, let's think about some powers of 5 that we do know. So for example, 5 to the first power, that would be 5. And then what's the next kind of nice power we could try? Well, 5 squared is 25. And so neither of those is 12, right? What we're looking for is 12. But what we can say is that 12 is between 5 and 25, right? So maybe pause for a second and think, if you had to guess based on this and this, these pieces of information, if you had to just guess some kind of a decimal power that you think you could raise 5 to and get 12. So it's going to be something in between 1 and 2, right? So this tells us that the value of log base 5 of 12 should be somewhere between 1 and 2. Because the way the exponents work, the bigger the exponent you raise the number to, as long as that number is bigger than 1, the base, the bigger the power we raise 5 to, the bigger the result's going to be. So if we want something that's between 5 and 25, that means that exponent has to be between 1 and 2. Okay, so I'm going to tell you what the value of log base 5 of 12 is. I'm not going to tell you yet how you could actually figure this out, so I'll write that down as kind of a note. But log base 5 of 12 is actually equal to approximately 1.54. And so I'll just write down, we'll see how to do this later. It's not magic. But so what do I mean when I say that log base 5 of 12 is about 1.54? Like, what is that actually telling us? That's telling us that if you take the number 5 and you raise it to the 1.54 power, you're going to get about 12. And it's about because this number is already rounded, right? If you were to actually evaluate log base 5 of 12, it's going to have a lot more decimal places than just 2. So I rounded it to 2 decimal places. But I would encourage you to go on your calculator and type in 5 to the 1.54, and you should see that you'll get an answer that it might not be exactly 12, but it's going to be close to 12. So the main point of this kind of intro to this video is I just want to make sure you're aware that you can raise numbers to exponents that aren't nice, clean numbers, that aren't whole numbers or fractions. And you can take logarithms of numbers where it's not so clear what the answer is. It's just that we're going to have to use this new formula to actually figure out what the answer is, because you can't really see it just by kind of looking at the numbers. Okay, so the way that we're going to go about doing this, so why can't you just type log base 5 of 12 into a calculator? Well, you might be able to. Some calculators can do it. So if you go into Desmos, for example, I'm not sure about I know Desmos has like a scientific calculator. That's not what I'm talking about. If you just literally go to Desmos, like the graphing, and you type in log base 5 of 12, it will tell you what log base 5 of 12 is. But if you have like a handheld calculator, it's not going to have a button for every logarithm, right? There's so many. You could do log base 5, log base 3, log base 2, log base 9. There's way too many different logarithms for your calculator to necessarily be able to do all of them. And so what most calculators have is they have a button for log. So log base 10 is just called log, right? And then ln, which is log base e. So let me kind of summarize that. How can you use a calculator to evaluate a logarithm like log base 5 of 12? So, one of these logarithms that you can't kind of do by hand. So most calculators are only equipped with 2 different logarithm buttons. I'll say it this way, can only evaluate logarithms in base e. So remember, base e for a logarithm is what's called ln, or in base 10. And base 10 is what is called just log. So if you have a scientific calculator, if you look at it, you might see that you have one button that says ln and one button that says log. And so what that means is that we're going to need to convert these other logarithms to be expressed instead in base e or base 10. So this means we need to convert logs with other bases to being written in terms of ln or log. Okay, so how are we going to do this? Well, we're going to do this with what's called the change of base formula. Okay, so what does the change of base formula say? Well, it says that if you have any logarithm or a logarithm of any base, so let's call that base b. And let's say you're taking a logarithm with a base of b of some number that we'll call x. So let's say that we wanted to convert this logarithm with a base of b to a base of a instead. So where a just represents some other number. So the way that you can convert this logarithm to being with a base of a instead of a base of b is that in the numerator, you will take log base a of that same number you were originally taking the logarithm of. So it's still log base a of x. Then you're going to take that result and you're going to divide it by log base a of the original base b. So this is the change of base formula. Now the two kind of forms that you'll most likely use this in, so you can use this with any base. Like you can go from base 5 to base 212 if you want. You can go from base 2 to base 17. You can use any base you want. But as we mentioned above, the most kind of useful forms of this are going to be the two following. So if you have a logarithm with some, random base b, and you want to evaluate it on a calculator, you're probably going to want to change your logarithm either to being in terms of ln or in terms of log. So if you're using ln, it's just going to be ln of x over ln of b, of your original base. And similarly, if you wanted to change to log base 10, so that's what's just called log, then you would be doing log of x over log of b. So just to be clear, these two things I'm writing down, they're just kind of like special cases of what's written on the left. So the left is the general formula. You can change to any base a that you want. And so these two examples I'm doing on the right, these are examples where you're choosing your new base a to be either 10 or e. When it's 10 or e, you would get either ln or log. So let me circle this because this is basically the main point of this video. So for example, let's say that you wanted to evaluate the example that we were talking about earlier. So let's say you wanted to evaluate log base 5 of 12. So there's two different ways that you could do this using a calculator. So first, let's try it with ln. So if you wanted to translate log base 5 of 12 into ln, in the numerator, you would be taking ln of 12. And in the denominator, you would be taking ln of 5. And so if you type this into a calculator, so if you type into a calculator ln of 12 divided by ln of 5, you'll see that you get approximately 1.54. You could also change it into being log. If you wanted to, it's really up to you which button you want to use on your calculator. For some reason, I feel like I'm biased towards ln, but really you'll get the same answer either way. So you could also use the log button, and in that case, you would be doing log of 12 over log of 5. And if you type that into your calculator, you'll get the same exact result. So one thing I just want to point out is that ln of 12 and log of 12, if you type those separately into your calculator on their own, those are not equal. Log of 12 and ln of 12 are two completely different numbers, right? Because one of them is asking what number you have to raise e to get 12, and the other one is asking what power you have to raise 10 to get 12. So that's going to be two completely different numbers. Similarly, log of 5 and ln of 5, those are two completely different numbers too. So it's really only true that you get the same result if you do them together. It's the ratio that's always going to be the same. So as long as you're doing the same type of logarithm in the numerator and in the denominator, you're good. You're going to get the same answer. It's up to you which one you want to use. I want to just quickly mention, it's also true, like let's say that you wanted to change to a different base. You could, if you wanted to, express log base 5 of 12 in terms of any other base. So let's say you wanted to rewrite it in terms of base, 27. You could do that. You could say it's log base 27 of 12 over log base 27 of 5. That is a true statement. However, that is just not a very useful conversion. right? Like the whole point of the change of base formula, generally speaking, is to change a logarithm into being a base of 10 or e so that you can evaluate it on a calculator. And that's why it just doesn't, while it's theoretically true that you could change it to whatever base you want, you're not usually going to change it to some random other base. It will usually just be log or ln. So I want to quickly show you why the change of base formula is true. So this is this is a proof of the change of base formula. So what we're about to do, you don't need to ever repeat this process. I'm just kind of showing you why this works. Really, in practice, all you're going to have to do is remember and apply this formula. But I just want to show you why it works so that you believe me that it's true. Okay, so let's say that we started with log base b of x. That's going to be equal to some number, right? So what are we trying to show? Maybe before I jump into this, what are we trying to show? We're trying to show what is circled in this purple box here. We're trying to show that log base b of x can also be written as log base a of x over log base a of b. So let's say you're trying to evaluate log base b of x. Well, it's going to be equal to some number, right? Log base b of x it's going to be some number. Let's say that number is y. So I'm just using y as like a name for the number that log base b of x is equal to. So what's another way of writing this? Like, how could we restate this, this logarithmic equation? Well, we learned how to do this in an earlier video, right? We learned that if log base x if log base b of x is equal to y, another way of saying that is that b to the y is equal to x, right? That's just like the definition of a logarithm. Okay, so the next thing we're going to do is going to be a little bit funny, but we're going to take a logarithm of both sides of this equation. So we're going to take a logarithm with a base of a of both sides of this equation. So we're going to do log base a of b to the y is equal to log base a of x. So why can we do that? Well, in general, when you're solving an equation, you can do the same thing to both sides, right? You can add 5 to both sides, you can square both sides, you can take a logarithm of both sides. So we're just doing the same operation to both sides of an equation. Okay, so now what can we do? Well, we learned a rule actually in our last video that will allow us to rewrite this a different way. So what was the rule that we learned that might be useful here? Well, we learned that if you're raising the input of a logarithm to an exponent, you can take that exponent and bring it down and multiply it with the logarithm, right? So we can rewrite this as y times log base a of b is equal to log base a of x. Okay, so the last thing we're going to do is we're going to solve this for y. So why are we solving this for y? Well, remember that at the very beginning, we said that log base b of x is equal to y, right? So y is just kind of another name for the result of log base b of x. And so if we can solve this for y, that will tell us another way of, or something else that is equivalent to log base b of x. So what happens if we divide both sides by log base a of b? Well, now we get log base a of x over log base a of b. So what does that tell us? Well, we got y for both of these things are equal to y, right? If we have y is equal to log base b of x, and then we also have y is equal to all of this stuff, well, that tells us that the two things in the green boxes must be equal, right? If they're both equal to y, they have to be equal to each other. And so that tells us that log base b of x is equal to log base a of x over log base a of b. And that's exactly the change of base formula, right? Log base b of x is equal to log base a of x over log base a of b. So that's why it's true. If you didn't totally follow along with all of that, that is okay. Really, again, all you need to know how to do is how to apply this formula. So let's do a few examples. We're just going to do examples where we will look at a logarithm. We're going to estimate what we think the answer is going to be. And then we're also going to use the change of base formula to actually evaluate it. So the first example I want to look at is log base 3 of 25. So let's start with an estimate. So how do we estimate this? Well, remember that log base 3 of 25 is asking us what power we need to raise 3 to get 25. So we want to think about what are some different powers we can raise 3 to, and where is that going to get us? What gets us close to 25? So 3 squared would give us 9. And then 3 cubed would give us 27. So what does that tell us? Like if you had to guess, what will the approximate value of log base 3 of 25 be? Based on these, what do you think it's going to be? So it's going to be pretty close to 3, right? It's going to be between 2 and 3, but it's going to be closer to 3 because cubing 3 is a little too much. Squaring 3 is definitely too little. We're going to need to raise 3 to a power that is somewhere between them, closer to 3. And so based on this, we should be able to guess that log base 3 of 25 should be between 2 and 3, and it should be closer to 3. So that's our guess. Maybe it's going to be like 2.8 or something like that. Okay, so how do we actually evaluate this? Well, that's where the change of base formula comes in. So we're trying to evaluate log base 3 of 25. And so it's up to you whether you want to use ln or log. Either way is fine. But the important thing is that in the numerator, so let's do it with ln. In the numerator, you're taking the logarithm of your original input, so that's 25. And then in the denominator, you're taking that same logarithm of your original base. So that's going to be ln of 3. And so if you type this into a calculator, you'll find that ln of 3 is ln of 25 over ln of 3 is approximately equal to 2.93. You could have also done this with log, right? You could do log of 25 over log of 3. You would get the exact same answer. I'm just going to do it this one way just to kind of save time, but I would encourage you to try it with log and you'll see that you get the exact same result. So this fits with what we expected, right? We got an answer that is closer to 3, but it's between 2 and 3. And I would actually encourage you to check this too. So whatever you got as your answer in your calculator, if you take 3 and you raise it to that power, you should get approximately 25. So again, depending on how many decimal places you take, you might get something that's very close to 25. It might be a little off, but that's just because of rounding. Okay, let's do one more example. So we're going to do log base 16 of 3. So this is asking us what power we would need to raise 16 to get 3. So this one's a little bit trickier because it's not going to be, we don't have nice whole number powers to compare it to. So instead, we want to think about what are some fractional powers of 16 that maybe would get us close to 3. So one that might kind of stand out to you, or like the first one that you might think of in terms of fractional powers that you could raise 16 to, and I'm going to put it on the right because we're actually going to do a smaller one on the left. If you raise 16 to the 1/2, that's going to give you 4, right? So that would be like our overestimate. So what other fractional power could we raise 16 to that would give us a nice number? Like what other kind of clean power is 16? Well, 16 is also a fourth power, right? So 16 is the fourth power of 2. So another way of saying that is if you were to raise 16 to the 1/4, you would actually get 2. So so 2 to the 4th is 16, so the 4th root of 16 is 2. That's all we're saying there. So what can we expect from this? Well, we can expect that means that log base 16 of 3 Well, we know that 1/4 is going to be too small of a power, and we know 1/2 is going to be too big, so it should be between 1/4 and 1/2, right? And it's hard to say which one it's going to be closer to, right? Because 3 is exactly halfway in between, so it's probably going to be pretty close to halfway in between. Okay, so how do we actually evaluate this? Well, this is where we use the change of base formula. So if we want to evaluate log base 16 of 3, again, we can use either ln or log. So let's say we wanted to use ln. In the numerator, we would take ln of our original input, so ln of 3. In the denominator, we would take ln of our original base. And if you type this all into a calculator, you'll get approximately 0.58. And again, I would encourage you to try this with log as well, and you'll see that you get the same answer. And then I would also encourage you to try raising 16 to that power. And what you should find is that you approximately get 3, because that's how logarithms work. All right, so that is it for this video. And equations involving logarithms and exponentials. So I'll see you on the next video.